over 2. And to solve this, I have to divide everything by pi, which basically knocks out the pi's. Okay. I know I'm going here from 0 to 3 over 2. Like so. Okay, you could do this in your head. You could do it via the calculator if you needed to. If it's not a trig one, it's going to be somewhat simpler. But I'm going to just use this picture. This is what we talked about before. It's going to be positive until that half, and then negative after that. So, on my axis, positive first, and then negative. Okay, I can't ever do total distance traveled without having one of these axes, because I'm not going to know how to split this up if I don't do that. Okay, so I'm going to split this up from 0 to a half. Why a half? Because that's where I end on the positive piece there. I can just remove the absolute values there, right? They're not doing anything anyway. Just take them off. So 5 pi cos pi t dt. From half to 3 halves, though, this is the part where that whole thing is negative. I'm going to negate it. Uh-oh. Uh-oh. Yeah, I'm getting better. There. Okay, so far? Okay, my little u down here again. Pi t du pi dt. Okie doke. Okay, here we go. Change my limits of integration. They'll be 0 and what's this one? Pi over 2. I will have 5 cos u du minus, this will be pi over 2, 3 pi over 2, 5 cos u du. Okay, ready to integrate? We've already done it, so I know this is just plain old sine, so 5 sine u, 0 to pi over 2, 5 sine u, pi over 2 to 3 pi over 2. Okay, ready for the plug-in? 5 sine pi over 2 minus 5 sine 0 minus 5 sine 3 pi over 2. I'm going to do a plus now because it's minus a minus. 5 sine pi over 2. Okay, ready for our plug-in. 5, the sine of pi over 2, 1, minus 5 times 0, minus 5 times, this one's negative 1, plus 5 times 1. Okay, 5 plus 5 plus 5. So total distance traveled was actually 15. Any questions so far? And really those are the only two topics today, although if you turn the page, we're actually going to use that very same velocity equation yet again, because I'm going to show you another way to do these, depending on what you're given, and that's kind of how you decide what you do. Sometimes you can use both methods, sometimes you can't. Sometimes you'll just have to use the methods that we just did. So this is going to be the same exact question again. Let me put the velocity equation back here again. Same one we had before. Okay. Same question, find the distance and displacement for v of t from 0 to 3/2, except that this time we have a given that we didn't have before. Okay, we have a given that we didn't have. Now I could just go and solve this exactly like we just did. That would be considered method 1 if you would. So what I want to show you now is the other way. Some people like this way better. Sometimes you have to do it this way. It just depends. So if I'm given a point on the position, S is position by the way, I can find the position by integrating. Okay, so that's what we'll do first. We'll find position. We couldn't do that before. Reason being, we would have had a plus c. Okay, this is going to take care of our plus c for us. So let's integrate velocity. Okay, and what we'll end up with here when we do that, oops, that was supposed to be an S. Don't worry, I know how to erase. S. Okay, so let's put this in here. 5 pi cos pi t dt. You know this drill. For the 10th time. Only feels like the 10th time. Okay. So 5 cos u du. Okay, here we go. 5 sine u plus c. That's my position equation. Let me put my u back in. Okay, and now I'll use that point that I was given. Position is 5 at time 0. The sign at 0 is just 0. So C is 5. And finally I have a position equation. Good so far? Okay, you're going to need that before you can use the other method. You want to be hopefully writing smaller than I am, by the way. Okay, it's hard for me to write small with this. Displacement. Okay. What we need for these also is our velocity axis. I'm going to bring it back. Actually, let me do it in